In mathematics, the Tarski-Seidenberg theorem states that a set in dimensional space defined by polynomial equations and inequalities can be projected down onto n-dimensional space, and the resulting set is still definable in terms of polynomial identities and inequalities. The theorem, also known as the Tarski-Seidenberg projection property, is named after Alfred Tarski and Abraham Seidenberg. It implies that quantifier elimination is possible over the rails. That is, that every formula constructed from polynomial equations and inequalities by logical connectors and quantifiers is equivalent with a similar formula without quantifiers. An important consequence is the decidability of the theory of real closed fields. Statement: a semi-algebraic set in Rn is a finite union of sets defined by a finite number of polynomial equations and inequalities. That is, by a finite number of statements of the form and for polynomials p and q. We define a projection map pi Rn plus 1 Rn by sending a point to. Then the Tarski-Seidenberg theorem states that if X is a semi-algebraic set in Rn plus 1 for some n greater than 1, then pi is a semi-algebraic set in Rn. Failure with algebraic sets. If we only define sets using polynomial equations and not inequalities, then we define algebraic sets rather than semi-algebraic sets. For these sets the theorem fails. As a simple example, consider the circle in R2 defined by the equation. This is a perfectly good algebraic set. But project it down by sending in R2 to X in R, and we have the set of points satisfying -1 x1. This is a semi-algebraic set as we would expect from the theorem, but it is not an algebraic set. Relation to structures. This result confirmed that semi-algebraic sets in Rn form what is now known as a no-minimal structure on R. These are collections of subsets Sn of Rn for each n1 such that we can take finite unions and complements of the subsets in Sn and the result will still be in Sn. Moreover, the elements of S1 are simply finite unions of intervals in points. The final condition for such a collection to be a no-minimal structure is that the projection map on the first n coordinates from Rn plus 1 to Rn must send subsets in Sn plus 1 to subsets in Sn. The Tarski-Seidenberg theorem tells us this holds if Sn is the set of semi-algebraic sets in Rn.